So essentially, the humans are going to do the exact same task that your algorithm will do, except that, of course, we do it the way humans do it, which is manually through looking at the image, marking, the things that need to be marked, classifying them the way that they need to be classified, whatever the task involves. And then the output of that is a training data set.
Welcome to another episode of the Mapscaping podcast. My name is Daniel, and this is a podcast for the geospatial community. My guest on the show today is Mallory Dodd. Mallory is a solutions architect at a company called iMerit, and today on the podcast we're going to be talking about building training data sets for AI. The hope of this podcast episode is to give you a basic understanding of what training data is, and to try and help you understand some of the differences between the terminology. So what is the difference between labeling, tagging, segmentation, annotation, and where do we apply what technique? So this podcast episode, I think, goes really well with a previously published episode called An Introduction to Artificial Intelligence. So if that sounds like it's something that you might be interested in, go back through the podcast and check that out. I don't think it matters so much which order you listen to them in, but I think these two episodes will work really well together. I'll put a link to that in the show notes as well to make it a little bit easier for you to find. Just before we get started today, I want to say a big public thank you to the team behind geoawesomeness.com. So no one's paying me to say this. They've just been incredibly helpful recently, and I've just really appreciated all the support and help and sparring that they've given me. And I really admire what they're doing. They're not just a website, they're building a community. So during the conversations with some of the team members at GeoAwesomeness, I noticed that the first question they ask is, but is this going to make things better? How is this going to help the community? And I really admire that. So again, a huge public thank you to them for all their support. If you don't know about them or haven't checked them out before, geoawesomeness.com. I don't think that you'll be disappointed. Hi, Mallory. Welcome to the podcast. I'm really looking forward to this conversation because we're talking about something that I have a great amount of respect for, but very little understanding around, and that is training data sets for machine learning, for AI. This is something you know a lot about. You are a solutions architect at a company called iMerit. And I think before we really jump into the conversation around training data, what it is and how we can use it, perhaps you could take the time just to give the listeners a bit of context. So what does a solutions architect do, and what is iMerit?
Sure thing. So iMerit is a data labeling services company for AI and ML use cases. So we're not the ones building an AI algorithm. We're not a database provider or anything like that. We're just a service that labels data for the purposes of training AI and ML algorithms and models across a pretty wide variety of different use cases. That's what we do, but then my role specifically as a solutions architect. So I work with many of our sort of new incoming customers and accounts who have a use case, who are trying to get started, who want to spin up a project with us, but they need to understand, the requirements. They need to understand how the project is going to work, how we are going to execute it. And so it's my job to, dive into their use case to understand what they're trying to do in the short term, but also what they're trying to do in the long term and how we're going to help them, get to that point. For me as a solutions architect, I'm meant to be that sort of subject matter expert and help them understand, the best way to think about their project, both in the short term and in the long term.
So you sound like exactly the kind of person I should be talking to if I want to understand more about training data. So for me, I think we talk about AI, machine learning, deep learning, all these magical things all the time, but we hardly ever talk about what we need to get them going. So that this training data set. So I'd like to start with this really, really simple question. What is a training data? What is it? How do we make it? And what do we use it for?
Sure. So a training data set is the data that you use to teach your algorithm or your model how to do something, whatever it is that you're trying to get it to do. That's how you teach it, right? Because, there's like pre-made sort of, algorithms and training data sets and different things that are out there. But if you need it to be able to do something specific, be able to recognize specific types of objects or make specific types of judgments about something or track certain things through your data, you need to train it to do that. You need to train it how to understand what it's looking for and also how to correctly evaluate it the way that you want it to be evaluated. And so this is where, humans come in, which is a phrase that, many people probably have heard in regards to this, which is human in the loop, which means that, you're not creating this algorithm completely separate from human input and human guidance. And so that's kind of where that training data comes into play, is that you'll put together an initial data set, and it can be varying sizes. If you're trying to do something really complex, you'll likely need a really large, training data set. If you're trying to do something a little bit more simple, you may not need as much data. Or if you're building off of something that's existing, you may not need as much data. But your initial data set will be, just raw data. And this will be something that you have either just, purchased from like a provider, or data that you have just directly collected through whatever mechanism you use to collect data, whether that's drones or cameras or satellite imagery or whatever it might be. And this is just raw data. And so the training data set is the process of human annotators going through and labeling your data set based on, the criteria that you need your algorithm to be able to identify. So essentially the humans are going to do the exact same task that your algorithm will do, except that of course we do it the way humans do it, which is manually through looking at the image, marking, the things that need to be marked, classifying them the way that they need to be classified, whatever the task involves. And then the output of that is a training data set, which is now usable data, meaningful data that you can then, process through your models, through your algorithms, and actually then derive, whatever kinds of insights you're attempting to derive out of that data.
So whenever I think about training data, I think about a data set of correct answers. So we have a question, and I think about giving this algorithm a bunch of correct answers. Am I in the right path when I think about it like that, or is it something completely different?
Yes, ultimately, the quality of the training data set is going to directly impact the quality of the output of your algorithm. A common phrase that I find myself using is, an algorithm is only ever going to be as good as its training data is. So typically speaking, yes, you want that data to be as accurate and as close to ground truth as you can possibly make it.
In terms of an initial training data set, and let's assume we wanted to find all of the cars in a certain image. Could you walk me through the process? Like, how do you find all of the cars? What do you start with? And I think later on, we're going to be talking about labeling objects. We're talking about annotation. So, what are we looking for? What are we doing when we do those things? If the question is find all the cars.
That's a great question. That's usually how most clients start, right? Is they have this idea of, I want to find all the cars. Oftentimes the first sort of step that you'll need to think about after that is define a car, define what you mean by car. Does that include trucks? Does it include vans? Does it include semis? Does it include motorized scooters or mopeds or any other type of vehicle that has a motor on it? You need to understand, what are the exact parameters of your definition of car that you're looking for, in this instance. And in doing that exercise, you might find that you need some additional attributes or additional classes. So maybe you want to separate cars versus trucks versus vans. Maybe you want to classify different types of cars, like a sedan versus a hatchback. And so those are all things that you will have to answer based on what you're trying to do with your algorithm, what your use case is. And so once you have an idea of that, we also need to understand, what type of annotation you're looking for. So if you just want to draw bounding boxes around those cars, maybe you need really, really precise data. So maybe you need it to be, down to the pixel precision labeling of, the exact pixels of that image that, belong to a car or should be classified as car. And so that's a different type of annotation. So that's another step to think about in that process is, how do you want those cars to be annotated? And then once that happens, it's a process of just setting up a workflow wherein, you transfer your data to my team, and my team, works on that data according to your guidelines, according to the parameters that you've set up. And then we do our own sort of internal quality checks on that, where we have a different set of eyes that looks at all of those annotations and make sure that everything makes sense and is in accordance to the guidelines that you created. And then we send that back to you, and you may also want to do your own sort of check over that to kind of evaluate how well we did, how well we understood, what you were looking for, whether or not that meets your criteria. And then at that point, you have your training data.
We've jumped over an important step, and that's the data, I guess, that we're annotating, right? Because I'm assuming I can't just go out and make a Google search for cars and give that to you and say, this is what I believe cars are. Here are all the pictures of cars. Please draw boxes around them. And then I'll use that in my model on my data set. Could you talk a little bit more about that, the connection between training data, these annotations that are made, and the data set that's actually going to be the model is going to run on?
Yeah, absolutely. That's definitely an important piece of it. So yes, you will want the actual imagery or video or lidar satellite imagery. I mean, whatever your sort of data type is, the data type that's used for creating that training data set, you will want that to be as similar to the data that you'll be using long term with that algorithm, with that model, as possible, because your algorithm learns based on a lot of different factors, not necessarily just the annotations, but also on the images themselves. And so if you're using, let's say, Google imagery or something to create your training data set, but then your actual data set that you're using with your model or your algorithm after that point long term is actually some kind of I don't know, super high resolution, imagery that you're collecting from, your own vehicles that you're, going out and driving around, or whatever you're doing, there's going to be then a discrepancy there. And when you try to feed that other imagery into your model that was trained off of, just Google imagery, it's not going to be as accurate on that different type of imagery. So you want to try to use the same data that you're really going to use long term, in your use case to do the training data, because that's what your algorithm is going to learn, and that's what it's going to get really good at, is analyzing that type of data for those specific types of annotations. So it's definitely something to consider. You want to make sure that there's consistency there. And so that is another part of the planning that you'll want to think about is, if I know that I'm going to be using, some certain kind of satellite imagery, for example, long term for my project, I want to make sure that I'm getting a subset of that to use for my training data so that it's as precise and as close to what I'll be using as possible.
So that makes perfect sense. This really tight connection between the training data set and the data set that's going to be used in practice. I totally get that. But I guess new data sets are coming available all the time, right? We're constantly discovering new things, new sensors are being invented. When we talk about the discrepancy there, are we only focusing on the discrepancy perhaps between the pixel resolution, but between different data sets? Or is there also something in the sensor and the time the image was captured, if we think about the different lighting conditions that might occur, that the angles, that kind of thing? Or is the discrepancy, is that only around pixel resolution?
No, it's all of the above, exactly as you said. So, especially with imagery itself, like camera imagery or video camera imagery, there definitely can be a lot of variance depending on whether you're collecting images during the day versus during the night, versus when it's bright and sunny outside versus when it's cloudy or rainy. All of these different things affect your imagery. And it's, I would say, depending on, what you expect, I guess, to see, you would want to try to get a variety in your training data set so that, your algorithm can kind of learn how to, assess these annotations and identify the correct, objects or features that you're trying to identify in a variety of different conditions. And the more that you do that, the more variety that you put in there, the more nuanced your algorithm or your model would be in the end. The better it will be at being able to kind of detect that your desired objects or your desired features, regardless of those types of factors. When it comes to things like the resolution, now that is definitely, I think, perhaps more impactful in certain ways, because if you're trying to annotate features on really low resolution satellite imagery, for example, and then that's what you train your model on, and then later on you're trying to use really high resolution, and let's say it's from a different satellite, is from a different provider. Not only will the pixel resolution be very different, meaning the precision of those annotations will be very different, but also, I mean, even just the offset and things like that can come into play. Whereas, if they're coming from different satellites, different providers, there can be certain, just differences, just natural sort of variations between the data sets where your annotations may not actually line up exactly with where the features are located in one set of imagery versus in another set of imagery. So those are definitely important things to think about. And the annotations are only going to be as good as the resolution of the data that you're putting into it. So the higher resolution imagery, higher resolution or higher density, I should say, point clouds and things like that are going to lead to more accurate and more precise annotations that will get you the same result than out of your algorithm.
So, as far as I understand it, there's a couple of different kinds of training data sets you can talk about. You can talk about that initial training data set, and I think that's what we've been focusing on up until now during the conversation. So, we want to create a data set, give it to a model, and identify all the cars. What about when we think about continuous learning? So, for me, a part of the magic of AI is that it can learn. So, it's not just one and done, it can update itself if we continue to train it. Can you talk to me about some of the things I might want to be thinking about if I am creating a training set or updating my training set, if I'm participating in this continuous learning with my model?
Yeah, exactly. That definitely is something that we see more and more of as AI is becoming more mature and all the different sort of algorithms and use cases and models that exist out there are all becoming more mature. The human in the loop process is one that really is pretty continuous. It's not just kind of a one and done thing where, okay, I've trained my algorithm and I could never have to touch it again or update it. And just as you said, sometimes there's just news sources of data that are available that are better or can get closer to what you're really looking for. And so you may, want to revisit that. There's also cases where your needs have changed. Let's say in the beginning, all you needed was to identify cars, but maybe a year or two later, now you need to be able to identify whether or not a car is moving or is parked, in addition to just locating the car in the image. Or maybe now you need to be able to identify the color of the car, or whether there's passengers inside, or something like that. And so that's certainly something that we see as well. And there's different ways to approach that. If you're just trying to kind of add on additional attributes or additional objects, additional things that you want annotated, you can even use some of the same data. And then another thing that you can also do is use your algorithm's actual output as our input data when we do the annotation. So let's say your model is able to identify cars, but now you need to be able to add on additional attributes like color or passengers or something like that. You can run some data through your model and then give us both the images and the annotations that your model has created, and we can add additional annotations. We can edit and do sort of like a QC correction type of thing on your model's annotations as well. So it's not always the case where we're drawing the annotations from scratch. Sometimes we are just kind of correcting or adding things onto what your model may have already created. With new imagery, if you're using a totally new data source, you may need to kind of create a new data set, a new training data set from that. It may, it could be smaller perhaps because your model has already been trained to some degree on this sort of use case. And so you don't necessarily need to start from scratch, but you need to perhaps increase the precision of your model, or maybe you just need it to be able to be accurate across different types of data or data sets or something along those lines. So creating some additional training data sets that you can then use to feed into your model will help it to better achieve that nuance.
I'm sure this is an incredibly naive question, but oftentimes it feels like we're constantly feeding things into these models and we're never removing things from them. Is there ever a situation, or is it even possible to do that and say, no, I don't want to use that data anymore? Or is it just putting in more of the data that you do want to use that improves the model?
That's a good question. To be honest, I don't know that, at least in my time in this role, I don't know that I've ever seen anybody wanting to do that. That's an interesting thought. I mean, I would assume if you wanted to do something like that, you could most likely, again, kind of have us have a team of human annotators. I mean, to say, look at the output of your model and then potentially remove those annotations that you no longer desire to be there. And you could potentially kind of feed that back in. There's different ways of sort of assigning, importance or almost like positive feedback sort of in your algorithm in terms of what it identified correctly and incorrectly. And so You may not even necessarily need human annotators in some cases. You may be able to just sort of, start marking those annotations or those outputs as incorrect as a way to kind of adjust, your model in that sense. But that's really interesting. I've actually never seen that one come across my desk, at least. Perhaps I will soon as as this continues to grow and more and more people get involved with these types of use cases.
Yeah, or it could just be that I'm completely, lost in this world and have no clue what I'm talking about. I doubt that I'm that I'm the smartest person in the room when it comes to this kind of stuff. I was just curious. We've talked a lot about annotations. We've talked about labeling as well, and I think this would be a really good point in the conversation to maybe walk us through what are we actually talking about here. What is an annotation? Is it different from labeling? And I know from a previous conversation with you, there's this idea that we can use vector annotations, we raster annotations, we've got classification tagging. I'm wondering if you could just take the time to explain a little bit more around annotations. What are we talking about?
I use the term annotation and labeling pretty much interchangeably, though there is a certain type of annotation that oftentimes gets referred to as labels or tags, which is that classification type, which is when you're not necessarily actually drawing anything in an image or something like that, but you're simply sort of giving it a tag to indicate that it belongs to some particular category. So what that might look like is taking your example from earlier with, I'm looking for all of the cars in an image. You may have annotations which are actually drawn on the image, which is to capture those cars, but then you may also want the annotators to simply mark whether or not it's daytime or nighttime in that image. And so that's a classification tag or a classification label. And so what that means is it's something that is applied to the entire image. It's not, one object that is being drawn or marked. It's just a descriptor or metadata if you can kind of think of it that way. It's like metadata about the image that it is applied. So that could be confusing for some people if they're accustomed to referring to that as a label. But when I say annotations or labels or annotation or labeling, I'm usually just referring to the same thing, which is the process of applying those annotations to your data, whatever type of data it may be. So yeah, different types of annotations. They all kind of have different pros and cons. Bounding boxes is probably the most simple, aside from that, classification tagging that I was just describing a minute ago. A lot of people are probably familiar with bounding boxes, so it's basically just drawing a box right around whatever object or objects you're interested in finding in your image, and that typically involves two marked points. So it's top left point and bottom right point. So you start with the top left point and then you draw your box down to the bottom right point. And those are usually the coordinates that will be kind of provided in the output, JSON file or XML file, whatever type of file you're using. Typically will have those pixel coordinates of your bounding box. So that's kind of the most simple kind. It's mostly used for object detection as well as object tracking if you're using video. You can draw 3D bounding boxes in LiDAR data, which are typically called cuboids, but it's kind of the same concept of just a box that is marked around a certain set of points that represent a single object, like a car in your point cloud. There is also Polygon, which I'm sure many people are also familiar with. So this is essentially just digitization. You can think about it that way, right? So it's drawing a polygon around a feature, whatever feature that might be that you're trying to extract. So it's a little bit more precise than a bounding box because it will capture the precise contours of the object that you're seeking to identify. So then, and as far as vector goes, there's also point and line as well that you can do. We typically kind of call them like key points, which is just, marking specific points at specific places. This is oftentimes used for things like facial recognition is probably the most well-known use of this. So, you'll mark certain points on the face, like center of the eye, left corner of the left eye, left right corner of the left eye, corners of the mouth, certain points on the nose or cheeks or hairline or different things of that nature to kind of just mark those points in the face so that as a person is talking or doing various expressions, you can kind of track the movements of those specific places on their face. So that's kind of an example. Then there's also line, which is, again, pretty simple, just marking lines. And this is often used for, let's say, routes that you're trying to mark, or it could be marking different geographical features like rivers and roads and that kind of thing. So those are the main vector types of annotations. There's also some raster types. And so that's what we call semantic segmentation. And there's actually several different types of segmentation. Semantic segmentation is kind of the most common, where you are only marking the desired objects in an image. So again, going back to your car example, if you're just looking for cars in an image, you would only create, you could call it like painting, almost like marking all of the pixels in the image that belong to a car and classifying them as car. That would be semantic segmentation. There's also panoptic segmentation, which is when every single pixel in the image is marked as something, is classified as something. And so that would be if you really want to have a very high degree of precision on every pixel in the image, exactly what the object is, so that you can kind of see this full picture. There's also instance segmentation, which is it's similar. It can kind of go in between semantic and panoptic, where it can be used in either case, where, for example, with semantic, if let's say you're trying to mark all of the pixels that belong to cars, but you also want to know specifically which car. You don't want them all to just be labeled as car. You want to know like car one, car two, car three. You want to see them as like discrete objects. And so that's what instance segmentation is, because you're classifying the specific instances of those cars in the image. And then panoptic can apply that same concept as well, where you're marking every car and every person and every tree and every cloud and whatever else happens to be in your image.
I'd just like to go back to the vector annotations for a second. We talked about points, lines, polygons, bounding boxes. This is all really familiar stuff for people in the geospatial industry. I'm curious, do people focus on creating these sort of parent-child relationships with these discrete objects that they're creating as well? And what about the attributes we're attaching to them? Does this just depend on the use case, what the model requires, what the output is going to be in terms of the questions that the model needs to answer?
Yes, absolutely. So, yeah, I mean, we can apply attributes to pretty much any kind of annotation, from bounding boxes to points, lines, anything that you kind of want to do, we can apply various attributes to that. So that kind of goes back to what I was mentioning earlier. For example, if you're doing this cars project, well, maybe you want an attribute that, where we have to mark what color the car is, or whether it's parked, or whether there's people in it, or something along those lines. Those are attributes that you can have, added on to that bounding box or polygon or point or line, whatever it is that you're trying to do. There's any number of attributes can be added onto that. And so, exactly as you said, it's really up to you to determine if that's something that you need, if that's information that you're going to be evaluating later, and if it's important for your algorithm to be able to correctly, identify those same attributes, then that's something that you want to include. If it's not important for you, you just want your algorithm to be able to tell you how many cars are in a picture, then you don't necessarily need to know all these different attributes. And so it would just kind of be a waste of time, for you to have that added into your project. So it really depends on your use case, and how detailed you're trying to get that data to be, and how much you want your algorithm to be able to evaluate those types of conditions in an image.
So I'm not sure if this question is going to make a ton of sense or be easy to answer, but I'm going to try anyway. So we've got discrete objects, we've got these sort of pixel-based annotation methods or techniques. How do I know which one is going to be right for my project? Can we split them up into broad groups and say, if you're looking for this kind of thing, vectors are the way to go, or if you're looking for this kind of thing, you need to be thinking about this as the raster annotation problem?
That's absolutely a fair question, and it's one that I think, pretty much everybody needs to ask if they really wanna, start training a model and creating training data, is understanding, well, which type of annotation should I really use for this? So, the raster annotations are typically going to be a lot more precise. This is going to be important in cases where you really need your algorithm to be able to see the exact, sort of contours of an object or feature that you're attempting to capture. It could also just be in terms of how you're attempting to use this data later on, whether you're using it internally versus if you're actually then passing that along as some type of product or service to your customers. That may influence how precise you need it to be. Bounding box is probably going to be one of the least precise just because it doesn't capture, the exact contours of an object. But, when you're doing something like object tracking in a video, bounding box is perfect because you don't really want to take all the extra time to have someone draw a polygon around, a person who is, let's say, running or, playing basketball or something in a video where they're going to be moving a lot. There's going to be a lot of extensions of their arms and legs and turning and doing all kinds of different things. I mean, you can do that if you need to, but that's going to take a lot of time, for someone to go through that video and basically draw polygons around the person. Whereas if they're just drawing bounding boxes are sufficient to teach your algorithm how to just track the movement of that person or other object like a car, for example, through a video. And so you wanna try to think about how to maximize precision and accuracy that you need, making sure that it's meeting like sort of the minimum standards that you need, while also maximizing, cost and time and other types of things like that that go into the project so that you can process more. So if you go with a simpler type of annotation, you can most likely process a much greater volume of data using a simpler annotation. Whereas with a more complex annotation will take longer and you may not be able to process as many images or data points through that workflow. So those are all just, things to kind of weigh. And, it's hard to put just a broad sort of concept around it because again, it depends entirely on what you're trying to do. And so that's part of what I do is when customers come to me with a project and they are looking for recommendations or they may be new to this space, it's part of my job to really understand what they're trying to get at so that I can tell them, bounding boxes may not be the best for this project that you're trying to do. You may want to look at, semantic segmentation instead because you're trying to do something more precise or more complex. Or I could say, this is too complex for what you need. In reality, you can accomplish really the same result using something that's going to be simpler and take less time. It just depends.
It seems like that's always the answer. So in my notes here, I've got initial training data set, and beside that, I've written high volume. I wonder if we can afford to be less precise, perhaps, with the kinds of annotations we make if we're going for volume at the start, if we're making that initial training set, and then perhaps be more precise when we're moving into the phase of continuous training.
Yeah, I would say that's a pretty fair evaluation for sure. And you can think about your project or sort of your life cycle of how you're training your AI in stages, right? So at the very beginning, you may want to just get to the point where your model can successfully identify just objects that you're looking for, whatever those objects are. And so that's going to be perhaps, a more simple, bounding box or polygon or some even key point, depending on the scale of your data. And then as you've kind of got that piece under your belt and you've met those goals, then you might be looking at, okay, well, now I need you to be able to identify different attributes of it or different aspects of it or different components of the object or, whatever that might be. And so then you may want to, exactly as you said, look at a more precise, form of annotation that's going to capture nuances between, different states of that object because bounding boxes are not going to capture the nuance. They're just going to capture that, this is the object and here is where it is in the picture and here's where it's moving to if it's a video, for example. But the other types of annotation that are more precise are going to be able to teach your algorithm how to recognize differences between objects of the same type. So a person standing up versus a person sitting down, a car with a door open versus a car with all the doors closed, that type of thing. So, you can certainly think of it in stages and in iterations of building complexity and building nuance into your model as you move through that life cycle.
Just one more quick question about annotations. So when you're moving around the internet, quite often you're confronted with these capture things. They're trying to confirm that you're a human, that you're not a robot. And so the question will look something like this. Here are 6, 9, 12 pictures, small fuzzy pictures, poor resolution, and click on all the cars, click on all the buses, find all the streetlights. When I do that kind of thing, is this what we could refer to as tagging, like that labeling classification, that labeling annotation that we talked about before?
Yeah, that's actually a decent example. Yeah, because you're not actually annotating the specific location of the lights or the cars or the, bus or whatever the captcha's telling you to mark. You're just marking whether or not the image contains that object. So yes, that's a good example of classification tagging.
So I think you've done an amazing job of walking us through what a training data set is, what it might look like, the relationship between the training data and the actual data we're going to be used in a production environment. Amazing discussion around annotation, what it is, the different kinds of it, where we should be thinking about using which form of annotation. Absolutely incredible. I've learned a ton. So you work for a company called iMerit, and as far as I understand it, you have a bunch of humans doing this, right? So I can go to you and I can say, please annotate these images, give you the instructions, and a bunch of humans will do this work. For me, anyway, part of the promise of AI is that it'll figure stuff out by itself. Can you imagine a time where humans will not be in the loop, where we won't need to annotate with humans to create these kinds of training sets?
That's a question that, I do hear, I guess, every now and then, right? It's a concern a lot of people have about AI. What we've been finding is that, the answer, at least as far as we can tell, is no. That human context and human input is thus far always been needed and will likely always be needed to really get your algorithm to do something that is meaningful to human users. And whether that's creating the initial training data as we've talked about, but even as we also mentioned that there's ongoing training that oftentimes needs to occur, as you're making new adjustments, as new data is coming available, as you're continuing to improve the capabilities of your model. All of that again brings in humans into that process of training your algorithm with your data. So I don't really foresee any situation of humans never being involved in that process. I will uh, one story that I've shared before because I think it illustrates this perfectly, as well as I think it was like a couple of years ago, some engineers like at Facebook, I think it was, were toying around with trying to create some AI that could. It was something to do with encryption. They were trying to find a way, like an AI could find a way to sort of encrypt some information so that no other system would be able to decipher it, or something like that. It was very experimental, and so they were using a non sort of human in the loop process. They were using that sort of a like competitive approach where there's like two different AI algorithms that are sort of competing against each other to accomplish the goal. And so they actually had three different AIs, three different algorithms. Two of them were attempting to communicate with each other without the third being able to understand them. Right. So again, it was a experimental way of just trying to see whether they could train these AI to accomplish the goal. Well, they really succeeded, but unfortunately, they ended up the two algorithms that were attempting to communicate with each other ended up essentially kind of creating their own language, encryption language, as part of this process. But unfortunately, it was completely unreadable and completely undecipherable by humans. And so ultimately, they ended up just shutting it down because it's not useful. It's not useful to human users. It's not useful to Facebook as a company. It's not useful to human users of Facebook. The point here is to try to protect data, but ultimately we want to be able to access that data at some point when we need to and protect it when we don't need it. But if, if our AI are just kind of, if they don't have that human element and that human context built in, that tends to happen, right? They tend to just kind of do things that make sense to computers, but may be completely unusable by human beings. And the whole point of AI is to create something which helps us, right? Which helps us do a job or helps us learn or helps us accomplish something or analyze information more efficiently. And if it's not usable to us, then there's no point in creating it. So I think that's an important thing, and something that I always think about whenever that question comes up is that computers, if they teach themselves that, it won't be usable by humans. It won't be something that contains the very, very fundamental human context behind data that really is what gives data meaning. And if it's not usable by us, then it's not something that we're ever going to want to build, because there will be no purpose for it. So that's my thought on it. I know I'm a bit biased coming from a human in the loop company, but I really genuinely believe that humans will always it will always be an integration, a partnership between humans and AI.
Yeah, I can definitely see that. I can definitely see that if the machines are working for us, they're going to need input from us to tell them what we like. How do we want this to be? What makes sense to us? So I definitely see it from that perspective, and I really appreciate you going out on a limb and walking us through that. That was really nice of you. Thanks. You see a lot of customers. You said at the start that you're a solutions architect. So I'm imagining that people show up all the time at your knock on your door and say, "Hey, I want to be part of the AI revolution. We've got some data. Let's sprinkle some machine learning magical dust on it and make billions of dollars." Where do you think we are in terms of the hype curve here? And perhaps a really good way of maybe explaining this to us is, do you think are people showing up on your door with realistic expectations of what's possible and perhaps the amount of effort involved?
I would say the vast majority of the time, yes, people's expectations are fairly realistic. There definitely have been, I would say, maybe a couple of cases that I personally have seen, in my portfolio of accounts and projects that I've worked on, where there was a little bit of overkill going on, maybe, or trying to do some type of annotation to train a model to do something that wasn't really going to make sense, or it wasn't really going to lead to the result that they really were looking for. And a lot of times part of that comes from the client not really taking into consideration issues of like human subjectivity. Subjectivity is definitely something that can be difficult to deal with in AI and in training data. And so sometimes if people are trying to get at very subjective use cases, they can oftentimes sort of underestimate how to set that up, or the effort that's needed to set that up and make sure that you're trying to account for as much subjectivity as possible, and that you're getting as much consistency as possible from the human annotators, since we all have our own subjective biases on things. So that's one area where I think I've seen some attempts maybe being made at trying to set up an algorithm, or bring AI into an equation, and approaching it perhaps the wrong way, or not really thinking through everything that's needed to make it happen. But quite honestly, I mean, even with those clients I see that are fairly new into the space, they might be a little unsure of how much they're going to need, or what all is going to be involved, or the types of things they're going to need to think about. But ultimately, they're still trying to do things that are realistic, that are within the realm of possibility. And so that's what we can help them with, and help them through all of the other components. But that being said, the realm of AI is being pushed further and further every day. And I certainly have the very fortunate opportunity to see a lot of the sort of very cutting edge type of stuff, things that, are brand new use cases that, nobody has really tried to do in exactly that way before. And so it can be pretty exciting. But yeah, I mean, I would say, vast majority of the time people seem to have a really healthy understanding, at least, of what's possible. Sometimes they may be a little unsure of how exactly to approach it, or how precise they need to be in that type of thing. But that's understandable if you're newer to the space.
When you talk about the realm being pushed, so people are trying new ideas and testing things out, do you have any examples of use cases that you think are truly innovative?
Maybe one area that I've seen a lot of growth recently is in like utilities management. This doesn't sound super exciting. I apologize that it's not maybe super cool sounding, but this is an area where I have seen a lot of growth coming up, where more and more, utilities, companies, and asset owners are starting to understand that they can actually use AI to do some pretty complex evaluations of utilities assets. So things like public infrastructure, like electrical towers, gas lines, you know, roads and bridges, and all kinds of things that, they typically have been spending, millions of dollars annually to have inspectors and teams kind of go out and monitor all of these assets. And they're discovering now that, you can fly a drone out over, the area where your assets are, and then you can train an AI to basically process that imagery collected by the drone and actually tell you what are the condition of your assets, what needs repair, is there anything that is damaged right now at this moment that needs to go and get fixed, or is there debris, or or just telling you what you have. Sometimes it's just inventory, knowing, what exactly is out there, what number of components are there present, are there cracks and dents and rust and all kinds of things, which is, and then even classifying different types of rust and different types of damage that can come into play. So that's one area where I think it's really quite remarkable to see, how people are applying that, because, infrastructure and utilities is something that is, I think, difficult to manage otherwise. I mean, it's just, you're talking about miles and miles and miles of area and millions of assets across a state, a city, a country, and thinking about how you can really use AI to vastly improve this process is pretty remarkable. There's also been, I don't see this as much personally because I don't focus on our like medical AI use cases, but we've seen some pretty amazing stuff happening in the medical AI space as well that I think is really quite cutting edge. I wish I could speak about it more intelligently, but I just don't know all of the different medical terminology to be able to really go into depth about it. But we've been seeing a very big increase in, the amount of medical AI projects from, and everything from pharmaceuticals to hospitals to medical research to medical documentation and all kinds of different things, where AI is coming in and, starting to play a role in this. In some of the more exciting aspects might be things like surgery assistance and different things like, monitoring different like scans, like X-rays, ultrasounds, looking for cancer cells, looking for tumors, all kinds of things. It's really pretty amazing.
I was so sure that autonomous vehicles were going to be on your list. I was sure of it. I thought I'll ask that question, and Mallory will say autonomous vehicles. That's where the action is. But no,
Well, there certainly is, but I guess in my mind, that's perhaps one of the longest standing uses of AI, which has been out there. And so, yes, but there definitely has been a lot of movement there. It's an industry driver for sure. I've seen a lot of stuff involving autonomous vehicles myself personally. So that is definitely really exciting. And it has been a front runner of the whole AI industry for a long time, for sure.
Mallory, I think this is a really good time to round off the conversation. Thank you very much for your time. I appreciate the way you can walk people through a really complex subject in a way that people like me can understand it. So absolutely fantastic. Thank you. Thank you very much. If someone is listening to this and they want to reach out to you, they want to learn some more, find out more about what you're up to at iMerit, where can they go to do that?
Sure, yeah. So they can head to our website, imerit.net. We'll have details on there about the different verticals that we work in, different, types of use cases that we can do. There's contact info there to reach out. I'm also on LinkedIn. A lot of, our team is on LinkedIn as well, if that's an easier avenue to reach out as well. And we also participate in webinars, talks, conferences. Pre-COVID, you could find us at, all kinds of conferences that had to do with AI. We'd almost always have a booth or something up there. Hopefully, we'll be able to get back to doing that again soon. So yeah, definitely reach out and let us know if you have a project or are interested, because we can absolutely guide you through that process.
Thanks very much for your time. It's been a pleasure talking with you.
Thank you so much for inviting me to come and speak. This has been amazing.
I really hope you enjoyed that episode with Mallory Dodd from iMerit. Personally, I think this is hugely important to understand AI. So obviously not just training sets, data sets, but the things around AI. It's taking up more and more space in the geospatial landscape. It's becoming that go-to tool, that go-to technology. And I think as practitioners and professionals in this industry, we have an obligation to at least understand this in terms of the broad strokes. So what are we talking about when we're talking about training data? How is it made? What are some of the difficulties and challenges around it? What is it possible to do with AI? What can the outputs look like? How are these systems going to grow and change over time? I don't believe that we all need to be experts in any of this. But again, I think we have an obligation to at least understand this from a very high level at least. That's it from me. That's it for another episode of the Mapscaping podcast. Thank you so much for tuning in all the way to the end. Much appreciated. As always, you can reach out to me on social media. You can find me at Mapscaping on Twitter, and the link to my LinkedIn account will be in the show notes, I should say. So, and you're more than welcome to connect with me there. Any suggestions for people you'd like to hear from, topics you'd like to be covered, feedback on the podcast, things you like, things you don't like, please send them my way. It would be greatly appreciated and really help me understand where it is I should be taking this podcast in the future. Okay, that's it from me. We'll talk again next week. Bye.